All right, welcome back everybody. We're going to get into chapter 2. So this is chapter 2.00. It's not really a section in the textbook because this is a complete review of something you've done in the past, and that's solving single-step equations. Now, I need to make sure that you're solid on single-step equations before I can dive into two-step and multi-step equations. So I thought it was just a good idea to review. Now, before we dive in, I want to talk about opposites. So let's put down some numbers. So let's say I put down 2, negative 7, 12, how about negative 15, how about x, how about negative y? Let's throw some variables in there. And let's talk about what are the opposites of those. This should be, you should be looking at this going, well, this is really too easy, Mr. Rick, but let's make sure we're all on the same page. Okay, so the opposite of a positive number is a negative. So the opposite of positive 2 would be negative 2. Now the opposite of a negative would be the positive. So this would be positive 7. Opposite of 12 is negative 12. So you see where this is going. You just changed the sign. Negative 15, the opposite is positive 15. Opposite of x would be negative x. And the opposite of negative y would be positive y. Now, what happens when opposites are added? This is really the crux of the whole lesson right here. When you add opposites, things cancel out, what we call cancel out. So if I go 2 plus negative 2, again, you should be looking at this going, oh man, that's so easy, that's 0. Okay, how about negative 7 plus 7, what's that? Well, again, 0. Any of these combinations where you add them, you get 0 as the answer. And that works even for the variables. Like x plus negative x equals 0. Negative y plus y equals 0. So the takeaway is that when you add opposites, you get 0 as the answer. Now we're going to use that when we're solving single-step equations. So let's look at some examples here. No categories today. We're just going to do example 1. Okay. If I have x plus 5 equals 7, and I need to solve it, well, what I want you to do is get used to reading the problem and identifying the order of operations. Okay. So we want to start reading a problem by identifying the variable first. Well, the variable here is x. Okay? And to x, we are adding 5. So I go plus 5. So this is what's happening in the problem, right? Now, this is following orders of operation. Now what I want to do is, what would be the opposite? If I were to go backwards in order of operations, what would happen? Well, the opposite of adding 5 is subtracting 5. Okay? And if I subtract 5 from both sides of this equation, what am I going to get over here? The 5 and the negative 5 will cancel, and I'll just have x. Now, this is what I call a roadmap, because it tells me what to do and in what order. This side right over here tells me the steps I'm going to take to solve this problem. So, follow the arrow's going up, so it says subtract 5 from both sides first. Now, 5 minus 5, that's 0. So you get x plus 0 equals, and 7 minus 5 is 2. Well, x plus 0, that's just x, so x equals 2. So that's a basic single-step equation. Let's do another one, okay? Change colors here. Let's go example 2. Okay, this time I'm going to go 15 equals 12 plus k. Now, what you want to do is you want to start asking yourself, how is each example different than the one above? Or how is each problem in your homework different than the one above? Because each problem is trying to teach you something. Okay, well this problem is different because the variable is now on the right-hand side of the equation. Doesn't mean it's going to change how we solve it. I'm still solving for k, and to k I'm adding 12, so I go plus 12. So I can create my roadmap by recognizing that the opposite of adding 12 is subtracting 12, and that'll get me back to k. So there's my roadmap. So I subtract 12 from both sides. And these 12s cancel out. You don't actually have to put the plus 0 part, because we know that 12 minus 12 is 0. And I get 3 equals k. So that's how that works. Let's take a look at another one. Example 3. Okay, this is y minus 15 equals 12. Okay, this is different than the others because in this example I'm subtracting. So I come over here, I go y minus 15. Now, over here to create my roadmap, opposite of subtracting 15 is adding 15, and that'll get me back to y. So there's my roadmap. Okay, so I add 15 to both sides. The 15s cancel each other out because one's negative and one's positive, and y equals 27. So that's an example where where the problem has subtraction, but we're using addition to solve it. Okay, now on this page, I've got a couple cautions I just want to throw at you. And let's get a different color for this. Because this is cautionary, I'm going to use red for this one. And this is page 2 of. Okay. So I'm keeping track of my pages. This is 2 of. So I'm going to write, don't do this. Okay. Sometimes I see students do this, and while this will get you to the correct answer, you're adding steps to yourself. So if you were looking at this problem, you might just jump into it and say, well, to cancel the negative 5, I just add 5 to both sides. Okay, well, you're partway there. The negative 5 and the 5 cancel. You get 0 equals a plus 12. But notice that didn't get you to the answer that a equals negative 12. What happens is now you've added another step to solve this. You've got to subtract 12 from both sides, and a equals negative 12. So think ahead in the problem. Look through the problem. Look to the solution, and try and avoid creating extra steps for yourself. And here's another one I want you to avoid. We've got 12 equals negative 7 plus, let's use t this time. Okay, I see this often, where students go, okay, that's a negative 7, so I'm going to subtract 7 from both sides. And then they go, okay, so 5 equals t. Well, can you spot what went wrong here? What happened is, this is a negative 7, and you're subtracting 7. Those don't cancel each other out. So we want to make real sure we don't ever do that, okay, because that's going to get you the wrong answer. This will get you to the right answer, but you're adding steps to it. So try and avoid both of these, okay? Now, what about single-step equations with multiplication and division? So we've got solving single-step equations with multiplication and division. Now, just like addition is the opposite of subtraction and subtraction is the opposite of addition, these two operations are opposites of each other. Multiplication is the opposite of division, and division is the opposite of multiplication. So we're going to use that to solve these problems. Let's go with pink. And we've got example, what were we up to? I think we're up to example 4. Okay, so here's the problem. It's 2 times x equals 5. Okay, well, we can make a roadmap for this too. The variable is x, and to x I am multiplying by 2. Okay, So to create my roadmap, I'm going to do the opposite of multiplying by 2, and that's dividing by 2, and that will get me back to x. So there is my roadmap. So I come back to the problem. I'm going to divide both sides by 2. Now a 2 in the numerator over a 2 in the denominator, those become 1. Now it's not that they cancel out, but 2 over 2 is 1, and 1 times x leaves x. So we've got x equals 5 over 2. Now you can leave the answer like that, but generally you're going to be asked to, if it's a top-heavy fraction like this, to go ahead and write it as a mixed number. So this would be 2.5. All right? Let's do another example. Example 5. Okay. I've got 12x equals 4. Okay? So we've got x times 12. So my roadmap is going to be divide by 12 to get to x. And that tells me what to do. Remember that when you're doing this over here, you're doing it in the order of the arrow. It's going up. It says divide by 12, so I divide by 12 on both sides. 12 over 12 is 1, and 1 times x is just x. So x equals 4 over 12. Now the reason I do this problem is if you have a fraction like this that you can reduce into smaller terms, you should do that. And this is equal to 1/3. All right? Let's look at a division problem. This is example 6. So let's say I had y divided by 7 equals 21. It would be really easy to look at this and just go rushing too fast and go 21 divided by 7 is 3 and think 3 is the right answer. Whoa, time out. We got to slow down. Y is the variable, and it is being divided by 7. So the opposite of dividing by 7 is multiplying by 7, and that will get me back to y. There's my roadmap. Okay, so I'm going to multiply both sides by 7. And what happens here is 7 can be rewritten as 7 over 1. So now I have a 7 in the numerator and a 7 in the denominator. Those cancel. 1 times y leaves me y. And 21 times 7 is 147. Check my arithmetic, but I think that's the answer. This was example 6. Yeah, I think we've got time. Well, tell you what, we get the idea there. Now what I want to look at is what happens if I throw in fractions. Okay, so let's say I had 2/3 x equals 7. Okay. What I want you to remember is that in mathematics, I think the general rule is still taught that you don't divide by a fraction. So if we were to do the roadmap here, it's x times 2/3. So to do the opposite, we would divide by 2/3, and that would get me back to x. Okay. Well, we don't like to divide by fractions, and hopefully you remember from previous courses that dividing by a fraction is equivalent to or the same as multiplying by the reciprocal. So you got to ask yourselves, if 2 over 3x equals 7, what is the reciprocal of 2/3? You just take that fraction and you flip it over. So we're going to multiply both sides by 3 over 2, and I'll explain why that works in a second. Okay, got it. Why that works is you've got a 2 in the numerator and a 2 in the denominator. Those cancel. 3 in the numerator, 3 in the denominator. Those cancel. You're left with just x. So this 2 cancels that 2, this 3 cancels that 3, and I have x equals, now I've got 7 times 3 over 2. Well, that's 7 over 1. 7 times 3 is 21. 2 times 1 is 2. So I can rewrite this as